We've been talking about electrolysis, and so far we've covered the basics of electrolysis, the guidelines for electrolysis, the electrolysis of aluminum oxide to extract pure aluminium, and then the electrolysis of aqueous solutions, where we talked about dilute sulfuric acid, uh, which is basically electrolysis of water in a way, and then concentrated sodium chloride solution. So today we'll talk about the electrolysis of copper to sulfate, and that will lead us to the purification process for copper. Let me just put that over here. Right, copper to sulfate is CuSO4. Right. So what do we do? Right, the first thing is that both the cathode and the anode are made of graphite. So those are inert. Haran, is the anode the positive terminal or the negative terminal?
Cathode is the positive terminal, I guess.
It is the positive terminal, and that is why the negative ions move towards the anode, and therefore negative ions are called anions. Right? That obviously makes the cathode the negative terminal, and so positive ions move towards the cathode, and that's why they're called cations. Okay, now, right, the products that you get out of this are oxygen gas. Well, not the products, right? When you electrolyze this, so what you have, since it's right, an aqueous solution, what are the ions that you have? So aqueous meaning there's water, so the ions from water, you are getting the hydrogen ion, and the hydroxide ion, right? And we already talked about you cannot electrolyze water on its own, and so you add something that is ionic, and that will help the ionization of water. And then you've got copper to sulfate, and that is giving you the Cu2 plus and the SO4 2 minus. Right, now what are we seeing at the cathode? So at the cathode, right, you obviously have a choice between the hydrogen ion and the copper ion. Now, if we recall the guidelines for electrolysis, which of these two ions would be preferably accepting electrons at the cathode?
Copper.
Copper, because it is an unreactive or less reactive metal, right? So again, if I just move back very quickly to the general guidelines, right? At an inert cathode, hydrogen is produced in preference to metals unless unreactive metals such as copper are present. So if this unreactive metal, then that would take preference over hydrogen. So that is exactly what will happen over here.
What is an inert? Like, I actually forgot.
inert meaning it will not readily react with, right, or take part in the process of electrolysis. In this case, inert in general means something that will at least not easily or readily take part in a reaction, or may not take part in a reaction at all, right?
Yeah.
And so what you're seeing, right, is Cu2 plus, and it's going to gain 2 electrons. Oops, not like that. And going to give you copper. Right, copper atoms. And so what you will notice is copper being deposited on at the cathode, right? So to start forming a coat over the graphite cathode. Now, right, what's happening at the anode? So we know the two anions that we have are the hydroxide and the sulfate, right? And both of them are moving towards the anode. So comparing these two, right, the hydroxide ions are, relatively, they give up their electrons because they were negative charge, so they've got more electrons than they, require, so to speak. And so compared to the sulfate, the hydroxide will give up its electrons more easily.
Okay.
And so what you will have is the formation of oxygen gas. So you got OH minus, right, aqueous, and that is giving you O2 as a gas plus H2O, right, and it is giving up electrons. You want to try and balance this?
Mm. It's already O2 is there, and we don't have O on the other side. So we're gonna put 2.
Where?
Wait.
Don't rush. Look at it carefully.
Yeah.
Like we need 3 oxygens and 2 hydrogens.
Yeah, but 3 and 2 isn't going to work, right? So what? How else can you manage this?
2 on the product side.
2 where?
On the wait.
Yeah, you have you're thinking right, but where?
On the product side
With
of OH.
where's the OH on the product side?
Oh wait, that's not part of it. Okay. Uh,
We are gonna add 2 on the hydrogen or on the product and 2 on the reactant.
Good. Right. So now what you have is 2 twos of 4. So you've got 4 hydrogens, and 2 and 2. You got 4. So 2 won't work over here. What will work over here? What number do you need on the reactant side? You've got 4 oxygens and 4 hydrogens. Right. So this will actually be 4. It's still not balanced though.
How?
Electrons. How many electrons are being lost?
1.
No.
Sorry.
How many hydroxide ions do you have?
4
Right.
only.
Yeah.
Yeah.
And so each will lose an electron. So in total, you'll be losing 4 electrons. All right.
okay.
So now
Yeah.
it's balanced. And so the product of interest over here is obviously oxygen gas. And so that's what we'll be collecting at the anode. Okay, now with an understanding of how this works, we're going to talk about the purification of copper. right? So copper is used in cooking utensils, it is used in wires, and it has really good electrical conductivity, but it needs to be very pure. If you've seen ads for machines that boast having copper wiring, like ceiling fans or heaters or other things, and what they claim is, oh, it's the copper that we've used is 99.99% pure. So
Yeah.
it sounds really impressive, and it is, right? So it's like a high level of purity. But the problem with copper is that it needs to be 99.99% pure to actually be efficient in its electrical conductivity and its conductivity of heat. So metals are good conductors of heat, right? So from physics and chemistry as well. So right, they're conductors of heat and electricity. So right, it needs to be 99.99% pure to actually have that very good quality of heat and electrical conductivity. Otherwise, if it's even 99.7%, it's not going to be as good, even though that is also a high level of purity. Okay, so right, how is this done? So what happens is, right, they perform electrolysis on copper using copper. So what they do is they have, right, the setup is both the right, in fact, no, not both. The cathode, right, is made up of pure copper, and they give the stats on how thick and how heavy it is. So that's given the text. I'm not going to focus on that. The anode is made of impure copper, so it's got impurities, right? But it has copper. And so what you want to do is you want to separate the copper from the impurities. And the electrolyte is copper 2 sulfate. So you got copper everywhere, right? Anode's the copper, cathode's the copper, electrolyte is copper, right? And right, this copper 2 sulfate is acidified. Right, it is acidified. So right, and it is aqueous, obviously. So what do you have happening? What kind of ions do you have? And so you've got water. And so what are the ions? You've got the H plus and the OH minus, right? And then you've got copper 2 sulfate, obviously. And you've got the Cu2 plus and the SO4 2 minus, right?
Yeah.
Also, right, what they've done is that they've added sulfuric acid, right? So that's not going to, right, it's just to acidify and activate it, so to speak, so that the ions separate easily, and right, it's only going to add more of this and this. So it's not adding some different ion. What's sulfuric acid? H2SO4, right? So it has hydrogen ions and sulfate ions, right? And you already have sulfate ions in the copper sulfate. You already have hydrogen ions coming in from water, right? So it's not going to add extra ions to make the electrolysis more difficult, but it's going to help activate the process by having another ionic aqueous solution. Okay, so what's happening is, right, the anode, what's happening at the anode is, right, copper from the solution copper ions from solution, right? Oh, sorry, copper atoms. My bad.
Yeah.
Ions come on the other side. So copper atoms, not from solution, at the anode are going to give up their electrons. And so what you'll see is the copper in the anode, right? The impure copper. And it's, what's happening is kind of the reverse of what we saw earlier. So it's going to give up electrons and, turn into copper 2 plus ions.
Yeah.
Right, so this was a solid, and now because it's turning into an ion, it's going into solution. So the quantity of copper ions in solution is increasing. And so what happens to these guys, these electrons that the copper is giving up, right? They travel through the circuit to the cathode. Right, and so the cathode is the negatively charged terminal where the positive ions are coming in, right? And so right now the copper from the electrolyte, and obviously you've got more copper coming in from the anode, which is losing copper, it's losing, right? The anode is actually losing mass.
Yeah.
Why? Because it's dissolving, right? It's impure copper, so the copper in the anode is dissolving, it's turning into ions, it's going into solution. Right, and so the anode will lose mass. Now what's happening at the cathode then? Right, so you've added sulfuric acid to help conduct electricity.
Okay.
Right, as it mentioned, to activate the electrolysis process, so it helps conduct. Right, why is it helping conduct electricity? Because it's ionic.
Yeah.
Right, okay, so then you got copper from the solution at the cathode. So copper from the copper to sulfate solution. Okay, that's not how you write it. That starts depositing at the cathode. So it's gaining the electrons that we just talked about. So you got, right, these guys, right, are from solution, and they're gaining 2 electrons, and they're turning into a deposit of solid copper, right, copper atoms.
Yeah.
All right, and so with time, and it doesn't happen immediately, it takes a good bit of time for this to happen. And so the anode is completely dissolved, and all the copper ions, they go into solution, and then they become deposited at the cathode. Right, now what about the impurities? So the impurities actually are collected as an anode slime. When the anode is dissolving, on copper is moving out, the impurities collect as an anode slime, right? And it's not useless because it does even though we're calling it impurity in the sense that it's something other than copper, right? But that doesn't mean it's useless because it contains precious metals such as gold and silver.
Yeah.
And so, right, that slime is utilized to extract that gold and silver and whatever else, right? Obviously, to make best use of the materials in that, so perhaps byproduct or waste product. Okay.
Yeah.
Any questions?
No.
Okay. Next up.
Uh, like it would be better if you could like show us visually that how it is done.
Yeah, so I'll show you the illustration in the book, right?
Okay.
So just give me a sec. I'll share screen. Right, so you can see here, right, the cathode, the negative terminal is pure copper, the anode is impure copper, right? And so they've shown it with a slightly different color, and they've also shown it to be an irregular chunk. And so what's happening is, right, over time, copper is losing its electrons that's going into the anode, right? It's traveling to the cathode. The copper ions are going into the solution of the copper 2 sulfate, and then it's being deposited at the cathode where it's gaining the electrons. So basically, like, it's copper's just being transferred, losing electrons here, gaining electrons here. So net, what's the net result? You could say nothing. The only thing that's happening is copper is being transferred from the anode to the cathode. That's basically all that's happening, right? So, but yes, that is the whole point of the purification, that you are separating cathode from the impurities. And so the impurities, right, the anode dissolves. You can see over here, right? So it's smaller, and this gunk over here at the bottom is anode slime, and it says that it does have precious metals, right, like gold and silver. So those are made use of later, right? It also says, so the slime is rich in precious metals, and the recovery of these metals is an important aspect of the economics of the process, right? So you don't want that to go to waste. Clear?
Yeah.
Yeah.
Okay. Now let's talk about, we have time, right? Okay. Let's talk about the hydrogen fuel cell. Oh, by the way, Sobia, I
Yeah.
I haven't taken a look at the IGCSE book for this one. My apologies. So I'll take a look at it later. If there's any topic that maybe I've left out that was, in the IGCSE and not in the O level,
Yeah, you can let me know later on.
yeah, you can take a look as well, see what we've covered, right?
Yeah.
And
Okay.
okay, so right, we need fuel cells, right? Fuel cells, right? What is a fuel cell? So a fuel cell in general is a chemical cell, right? And uh, right, there's a reaction sort of electrolysis going on in there to provide energy,
Okay.
right? Now what happens in a hydrogen fuel cell, right? So what you're using is basically hydrogen gas and oxygen gas. So hydrogen fuel cell uses hydrogen and oxygen gases, and electrolysis occurs, and right, the only output that you're getting, normal fuel, when you're using fossil fuels, you get carbon emissions and other gases which are pollutants and harmful for the health and the environment. Over here, the only exhaust you're getting, so to speak, is water, right? So it gives out water or water vapor, and so environmentally it's very clean. You're taking hydrogen, taking oxygen, you're getting water, so it's a win-win, right?
Yeah. Mm,
And obviously in the process you are producing electricity because it's a fuel cell, so right, it's providing energy, it's producing electricity. Now what's happening, right? So the electrolyte that is used is aqueous sodium hydroxide. Let me just, right, so NaOH, aqueous. So what's happening at the cathode? You've got oxygen gas coming in, and it is, right, combining with water, so to speak. I'm just going to write this out balanced, and gaining 4 electrons, and it is producing hydroxide ions. At the anode, you have hydrogen gas coming in, it is utilizing these hydroxide ions, and it is forming water, and it's giving up 2 electrons, right? And so that is, right, what's basically happening. So oxygen's coming in, hydrogen's coming in, oxygen is being converted to reacting with water and gaining electrons to turn into hydroxide ions. Then the hydrogen's coming in, it is utilizing those hydroxide ions that have been produced at the cathode, and right, making water. So it's all very clean. It's diagrammatically presented, right, in the text, so you can take a look at that, how it's happening.
yeah. Okay.
Okay. Now, other than that, right, so they give a list of advantages and disadvantages and how practical a hydrogen fuel cell is. I'm not going to go into that. You can read it on your own. It's pretty straightforward. I'm just going to talk about electroplating, which is the last topic of the chapter. So I kind of, oh, so I just want to try and get this done with today. So electroplating is a process where you, uh, you know, coat one metal or an object, even if it's a non-metal, with a metal that has certain properties. And those properties could be either the appearance of that object or make it more resistant to corrosion. So electroplating is applied to metal. So you mostly electroplating happens with metal. So you're coating one metal with another metal, right? Although it's not limited to metals only. To
Yeah.
improve either their appearance, right, and or their resistance to corrosion. And so you've obviously heard of, utensils or watches or stuff that is, gold plated or silver plated. So what they're talking about is basically electroplating, right? And so how does this happen? So for example, right, it is carried out where the electrolyte is a solution of a metal salt that you want to have you want to coat the object with. So the setup has an electrolyte of a metal salt, right, that you want the coating of. And so an example is, silver plating. What happens in silver plating is, right, whatever item you have, the electrolyte is a solution of silver salt, as we just mentioned, right? It is a solution. So electrolyte is a solution, aqueous solution of a silver salt. And then the item that you want coated, the item to be plated, is made the cathode. And this makes sense. Why do you want it to be the cathode? Because the cathode is the negative terminal. It will attract the silver ions. And so that will end up coating the item. Okay. Right. And so the reaction that's happening at the cathode is basically, right, in this case, you've got silver ions gaining an electron and forming silver atoms, right? And even though it doesn't make sense as the equation, what's basically happening is silver is being deposited onto the item that you want to coat. On the surface of the item, which is the cathode. Yeah, and that's basically it, right? So, right, and the anode is also made, right? So not only is the electrolyte a solution of the metal salt that you want, the anode is also made of the same metal. Can I squeeze that in over here? Right? Right? So what's happening over here is something similar to what happened in the copper to in the copper purification process, right? Kind of. So the anode, right? The silver in this case is copper, but the silver will go into solution, and then from the solution at the cathode, it will come back as silver atoms and then coat the object. So if I just show you the diagram of that in the book, that will make it easier, and that will be the end of the chapter as well. So good for us and the end of today's class. All right, so here you see the anode is a chunk of silver that you want to use for the electroplating. The cathode is the item, so this is a spoon that you want silver coating, a silver plating for, right? And then you got the electrolyte made up of, silver as well, a salt of silver. And so the cathode is negatively charged, and so it's going to attract the cations, the silver cations, and you're going to have a shiny spoon. Okay? Any questions?
No.
Hara?
No.
All good? And that is the end of the chapter. So congratulations. We have completed another chapter. Our progress is good in chemistry. Right? So tomorrow we'll probably start with chemical
Chapter 6.
energetics.
Yeah.
Okay?
Okay.
So I'll see you guys next class then, inshallah.
Okay then. Allah Hafiz.
Allah
Allah.
Hafiz.
Allah.